Well, this morning, what we are looking at is the automatic volume control voltage in this receiver. We'll talk about that in a minute on the schematic. Notice that we're reading about negative 2.1 volts. It's moving around. And the reason is this voltage is proportional to, in other words, it's a measure of how strong the signal is. So, like I say, we'll look at it on the schematic in a minute, but let me show you basically what's going on. I'm going to turn the volume up.
Markdowns throughout our stores. All remaining outdoor furniture, accessories, and placements.
And you notice
even lower.
that it doesn't change with the volume control itself. But now watch what happens when I tune off of the station. You notice it goes down to about minus 0.6 volts. This is the feedback that keeps the volume of the radio relatively constant. I'm not going to get into too much of the circuit theory, but let me show you the actual circuit on the schematic so you'll understand where we're measuring this and why that might be important to us in what we're going to be doing next. As I pointed out in a previous video, the detector works by rectifying, that is by removing half of the AC cycle of each cycle of the IF. In other words, as the IF comes through this transformer, it's being rectified by the diode in this 12SQ7. What that means is that what flows through this transformer are pulses of RF signal. Those pulses are, in one direction, they flow through the diode. In the other direction, they're blocked by the diode. So basically, it turns an AC signal into a pulsating DC signal where the DC pulsations are essentially the audio of the amplitude modulation. I know that sounds complicated, but in other words, what we're doing here is we're converting an RF signal with some amplitude modulation into an audio signal. And that audio signal is represented by pulsations that flow through this transformer. They also flow through this resistor down here, which is of course the volume control. And you pick that off with a capacitor and take it up to the audio amplifier. But you also pick that off with a resistor capacitor filter. What that does is it averages the signal at this point and turns it into a negative voltage across this capacitor. That's what we've been measuring. The meter is connected to this point, from this point to ground. So it is measuring, and you may recall, with a strong signal, it has about -2 or a little over -2 volts here. With no signal, or in between signals, it goes down to about -0.5 volts. Now, why do we care about that? Well, let's slide over here just a little bit further to the left and you'll see. Notice this little circuit shown here. It says 3 volts fixed bias for gain data. Notice that the negative lead, well, that's my meter beeping, the negative lead of the battery is shown connected to that same point, the positive lead to ground. Why do we want to do that? Well, while we're aligning this radio, we don't want this AVC circuit to be changing the gain. We want the gain to be affected only by our adjustments. So, for example, as we adjust this IF transformer, the way we do that is we put a -3 volt bias on here. It's called a clamp voltage. And what it does is it clamps, or in other words, holds steady this voltage at -3 volts. Well, -3 volts then is used through these various circuits to hold the gain of these stages constant while we're aligning the radio, so that the actual output of the radio is going to be merely a function of how accurately we have adjusted these various tuned circuits. Now, what I have done is I have wired together two AA batteries in this battery holder, and then connected to that a couple of leads. So basically there's 3 volts across here. We're going to connect the positive lead, the red lead, to ground, or to B minus, and the negative lead, the black lead, is going to be connected to this point, and that will provide that 3 volts of negative bias that we need at this point. Then we're going to start working on some alignment here. Now what I've done is I've connected this Simpson meter across the speaker terminals, and I have it set to the 2.5 volt AC range. I'm going to turn up the volume. And you see the meter is reading here. I'll explain a little of what I'm doing later, but first, pardon the high volume because it's necessary for what I'm doing here. I'm going to adjust this IF transformer. Notice the needle going down and the volume going down. Now I'm going to go back the other way. Goes up, peaks, and then goes down again. I'm going to go back. Now I'm going to reverse direction again and go back to the peak. Now, what I'm doing there is adjusting this IF transformer. I'm going to do the same with this other transformer, and there are 2 adjustments for each transformer, one on the top and one on the bottom that you can't see. I'm going to adjust all 4 of those for the absolute maximum. So, what is really going on here? Well, I suspect most of you already know. What we are doing is tuning the intermediate frequency stages. That is, those 2 transformers that couple from the converter to the through the IF stage to the detector. So we're maximizing the gain of this receiver at one frequency. And the frequency that we are using is 455 kilohertz. Now, I'm using this generator, which is a Syncor SG80, and I won't tell you about the setup on this because, quite frankly, this generator is overkill for aligning AM radios. It's really intended for stereo systems, especially FM stereo systems. It has all of the signals for multiplex and everything you need. It's a commercial generator. Certainly, a frugal repairman would never try to buy one of these just to align an AM radio. But it does point out the fact that you may notice that we have now introduced 2 new pieces of equipment. An RF generator that can generate a signal at 455 kilohertz, and a meter that has a scale that reads as an analog. In other words, it's an old school multimeter. Why didn't we use our digital multimeter? Well, mainly because most people, myself included, find it difficult to peak a voltage using a digital multimeter because it's not continuously reading the value. It updates every so many fractions of a second. Some of them take a full second or 2 to update. But, and so it's basically, if you're using that, you have to adjust and wait, and adjust and wait, and hope that you're going to get somewhere close to the peak. Whereas with an old school multimeter like this that has an actual meter in it, this, by the way, is called a d'Arsenval because of the French inventor that first invented this. By the way, he was not actually an electrical engineer, he was a jeweler. And the reason he was able to do this is he knew how to make the very, very fine jeweled bearings that it needed to create this meter with very little friction. And so these meters actually owe more to watchmaking than they do to electrical engineering. Anyway, another aside, I tend to do that a lot, maybe too much. So what we're talking about here is aligning this radio. And I wanted to go into it in a little bit of depth, particularly with regard to the fact that it does require that you get a couple of pieces of equipment that we haven't talked about so far. So I would like to talk about that a little bit. This meter today is becoming fairly scarce. It's a very nice meter, but it's pretty expensive. I would not recommend somebody starting out putting their money into a meter this nice. You don't need one this good. However, if you're going to do alignment using a meter like this, you do need a sensitive meter. You can't use cheap meters like this one, which is otherwise a pretty good meter. Not nearly as good as that Simpson, of course. But the problem is that the scales on this meter are 15 volts for AC. You see that over here. Well, 15 volts is not sensitive enough to really do this kind of alignment. So unfortunately, I wish I could recommend that you buy a nice cheap meter like this as your second meter. Unfortunately, because they only have that 15 volt range, and by the way, that has to do with the quality of the meter movement itself. At some point, you just run out of sensitivity no matter how you rearrange the circuitry. So anyway, that's kind of what I wanted to talk about this morning. I'm going to talk some more about alignment. But as I said, I'm not going to do a lot of alignment in this Frugal Repairman series. I will probably do some alignment in a subsequent video. And I know I said I wouldn't do alignment. What I meant was I'm not going to go through an exhaustive alignment procedure on this radio because it requires that you get a signal generator and a good sensitive AC voltmeter to be able to do it correctly. Now, there are some tricks that the repairman used to use back in the day, and I'll talk about some of those, might even demonstrate some of them. But more or less what I'm saying is we are at a point with this radio that, except for alignment, if the radio works, you probably should leave it alone. If you want to spend the money to get a signal generator, and we might in some future video talk about what the options are, although one option obviously is the signal generator that I used that I restored in the Vintage Radio Workbench video, and a sensitive AC analog meter. If you're willing to spend that kind of money, then you can do top-notch alignment on these AM radios. Otherwise, my advice is, if it works, leave it alone. Because if you start screwdrivering, is the term that repairmen used to use for this, where somebody would find that, oh, there's a little screwdriver slot in there, I'll just stick a screwdriver in there and make this radio better. And of course, eventually they got it to the point that it wouldn't work at all. And then they would bring it in and swear they hadn't touched it. So anyway, that's the lesson for today. my advice is, until you have a considerable amount of experience and you're willing to spend money on a good analog meter, AC voltmeter, and a reasonable signal generator, not anything as fancy as this one, but a reasonable one, I would recommend you try to stay away from aligning these radios and just enjoy them as they are. Before we move on to looking at the actual alignment instructions for this radio, just to give you an overview of what you might have to plan for if you decide that you do want to go acquire a signal generator and a nice sensitive meter. What I have used, and by the way, this is that 10th mic capacitor that you may remember used to be from the B- to ground or to chassis in this radio that I replaced with a safety capacitor. So I saved this one. And I saved it because it turns out that a 10th mic is what is called for in the alignment instructions. So I have the hot lead of the signal generator through this 10th mic capacitor and connected up to this very convenient connection that RCA has provided that allows you to inject a signal into the converter tube. You see, let me zoom in on that. It might be a little clearer what's going on there. You notice that this is connected to a terminal that is that goes back actually to the bottom of the tuning control. You notice that the signal that comes up from here and goes over and connects to that end, which is called the stator, means it's stationary, end of that capacitor, which you may remember is the antenna tuning capacitor. So let's take a look at the alignment instructions for this radio, and then maybe we can kind of wrap this video up and go on to a conclusion of this radio and its restoration. Here is page 1848 of the Rider manual for this radio, and you may see that in the upper left hand corner here is the alignment procedure. Now, I've pointed out in previous videos you can download this and many other Rider manuals from the American Radio History website. So this is page 1848. What that means is it's in volume 18 of the Rider's manuals, and it's on page 48 of the RCA section. The way that Rider did this is they didn't number everything from beginning to end in a manual consecutively. Instead, they broke up each section. So the way to find things in Rider manuals is first find the volume, then find the manufacturer's name, RCA, and then within that find the page number, in this case 48. So here are the alignment instructions, and we'll talk about them just a little bit. First, as I pointed out, you need to have a meter and a signal generator. Now, there are some people who align radios just using the audio tone. I have found that I'm not very good at that. I can get them close, but if you really want them tuned to their best performance, I have found that I can always do a better job using a meter than I can using my ear, even back when my ears were very good, or at least a lot better than now. So, you notice that it starts out with the phrase output meter alignment. Let me zoom in a little bit more here. Output meter alignment. Test oscillator. Now, output meter alignment, what they mean by that is you need a sensitive AC voltmeter, something that will read 2 volts, 2.5 volts, or less full scale. Test oscillator, that's the signal generator we talked about. Calibration scale, this particular radio, because of the way it's built, I'll talk about that in a second, you kind of have to put it back in the cabinet to adjust the oscillator and the antenna for reasons that I'll show you in a second. The first thing you need to do is make sure that you have the dial pointer hooked to the right place on the dial cord, so that when the, let me pull this over here, so that when the dial pointer is all the way at one end of the scale, there in other words, that the capacitor is fully meshed. Notice that how the rotor and the stator are fully, in this case, unmeshed, in other words, all the way at one end of the rotation. And then you want, at the other end of the rotation, you want them to be fully engaged, as you see there. If you don't do that before you start aligning the radio, you'll find that later, when you start trying to line up the pointer with the dial on the radio, that it either won't track or the dial will be slid to one end or the other. Let me show you what the problem is. The problem is that the dial is actually attached to the case. On many receivers, the dial is actually just printed right here on this plate or something equivalent. But with this one, you actually have to have it in the receiver. So what I suggest you do with receivers like this is, if you are going to do the alignment, first put the radio in the case, set the pointer to a known place on the dial, like 600, which is a common point. Then don't move the dial, take it out of the case and mark on here where that is, so that you can locate it again pretty accurately. Similarly, you should pick a place near the top, maybe 1400, as another dial mark, and mark that on the dial up here where it matches. Then, when you're doing the alignment with the unit out of the case like this, you'll be able to find those points easily. So now let's look at what they recommend you do for alignment. Step 1 is connect the high side of the oscillator to the 12SK7 IF grid. Now that's not the way I did it. I'll show you in a second how I did it. Through a 0.1 microfarad capacitor, and tune the generator to 455 kc. Find a quiet point on the dial near 1600, which is near the high end, and adjust T1 and T2. Now T1 and T2 are the IF transformers. Now remember, there are two adjustments, one on the top and one on the bottom. Some IF transformers have both adjustments on the top, especially those that use capacitors. These are what are called slug-tuned. In other words, there's a little ferromagnetic material down inside with a screwdriver slot in it, and it's on a threaded insert. And you turn that little slug in and out using an insulated screwdriver. Now, for a couple of reasons, you probably want to get a set of alignment tools that will work with your radio. You notice this is a fairly small screwdriver tip. It's made out of plastic. On the other end is a larger one. There are two reasons you want to use these kinds of tools. First, because they don't react with the circuit. In other words, if you used a magnetic material like a regular screwdriver, when you put it down inside the IF transformer, the screwdriver itself is going to affect the tuning. This will not. Second thing is, some of these IF transformers, these are not the type, but some of them have little screw terminals on top that are at B+ voltage. If you use a metal screwdriver, you can short the B+ to the can of the IF transformer, and if you do, you're probably going to have to replace your 35Z5, the rectifier. So, if you're going to do alignment, get the equipment you need to do it. That includes not only signal generator and a decent AC, high sensitivity AC meter, but also the right alignment tools. And as we saw earlier in this video, you may need a bias supply, like that little 3-volt unit that I put together, to clamp the AVC, the automatic volume control. Okay, so we adjust the 455, first using the 12SK7, and then using the stator of C1 through a 10th microfarad. Now, I skipped this connection. I just used this, partly because I was just trying to demonstrate. The reason that they have the 12SK7 is if T2, the second IF transformer, is way out of alignment, you may not be able to get enough signal through from the stator of the tuning capacitor. So you go to the grid of the 12SK7 and just tune the output, just T2. And that's what they're showing here with this top line T2. However, if T1 and T2 are somewhere close, you can just inject the source at the stator of C1, which is what I did. Then you go through a procedure to adjust the high end of the dial. They recommend adjusting it at 1300 kilocycles, and the low end of the dial 600 kilocycles. I'm not going to go into that today. If we do an alignment video, I'll explain about that, but the idea is to get the dial to track across its entire tuning range with reasonable accuracy. Now, these All-American 5s were notorious for having nonlinear dials, and often the way they were designed, somebody would build the receiver, kind of align it best they could, and then they would make the markings on the dial. In other words, they would put off till last doing the artwork for this dial until they knew where the needle needed to be for these various markings. That may sound a little bit un-engineering, but it's the way they did it back in the day. A lot of times the dial was marked to suit the receiver design instead of putting all of the time and money it would take to create a really linear tuning dial. Same thing was true of the tuning capacitors and so on. We won't get into all that today. So this is the basic way you align a receiver. First you align the IF until it is tuned to an IF frequency. Now I say that because different receivers often use different IF frequencies. 455 was common, but others used 460, 465. Some earlier ones used 262 kilohertz. Some auto receivers used 262 for reasons of interference. Anyway, you tune it to the IF frequency, and then you adjust the oscillator and the antenna to get the best performance. Now this receiver has a high-end adjustment and a low-end adjustment. Some of them just have one adjustment, and they sometimes recommend that you adjust that in the middle, like at 1,000 kilohertz. In this receiver, there is an oscillator trimmer right here, C4, an antenna trimmer, C2, and a 600 kilohertz oscillator trimmer here, which is used to set the low end of the band. So the way it would work is you'd set the low end with this, you'd set the high end with this, and then you would peak this for the best overall reception. I hope this has given you an idea of what it might take if you want to get into aligning receivers of this sort. In general, unless somebody has screwdrivered them, you generally do not have to align them to get them to work. Will they work a little better if you align them? Yes. But most radio stations are strong enough that in an AM radio, you really don't need a lot of alignment. Now, if you're doing an FM stereo, that's a different issue. If you're doing a shortwave radio, that's a different issue also. But for most just All-American 5 AM radios, I recommend, as I said before, if it works, just leave the alignment as it is, unless you really want to spend the money and go through the exercise. So I hope this video has been helpful to people who wondered about alignment and whether they should be looking for equipment. Nothing wrong with it if you have the money and you want to spend it on this, but don't think that it's going to keep you from having fun with this hobby. You can find an old All-American 5 radio and restore it without using the meter I talked about. Yes, it's nice if you have a leakage tester for the capacitors. Yes, it's nicer still if you have a signal generator and an AC voltmeter that you can use for alignment. But the basics are a simple multimeter like that BT meter or the eTech City, or frankly, even a cheaper one than that if you don't need the capacitor function or the auto ranging, and good technical data that you can download from places like the American Radio History website. So, wrapping up this section on belated alignment, without actually completing the alignment, well, like I say, we may do that on a receiver at some point in the future. I think I did that on the SX62A, but I can't quite remember whether I ever showed the alignment on that one or not. That's a much more complicated system, and one more worthy of investing in a good alignment generator and a good AC meter. At any rate, this is going to conclude the alignment part. We're going to have a final summary part where we put the radio in its case and talk about a few little things, and that's coming up next. But in the meantime, have a nice day.